This is for the equipotential electric field lab. This paper right here is carbon infused paper, and just to give an idea that if current can flow, we should have a resistance that is not an overload. We're going to measure the resistance. I'm going to take the two probes here and put them on two spots here. I do want to measure resistance, and so the symbol, this is the ohm, this is the symbol for resistance, and so this is how you would measure resistance. So I'm just putting it on two spots on the piece of paper here. Notice it is in kilo ohms. And so we have a resistance of somewhere just shy of 7.5 kilo ohms, or just shy of 7,500 ohms, a little bit more. So notice there is some fluctuation there, depends upon how good of a connection we have. Just to give you an idea of what it's like if I do regular paper, there is writing on both sides. And I'm going to take two spots on this one. Notice that it is overload, that's OL, overload in mega ohms. So this is, nothing's flowing through that. So this piece of paper right here is an insulator. This piece of paper right here is a conductor. And you can actually do resistance experiments with this paper. We can cut it up and show how cross-sectional area affects the resistance. I do not do the lab here, but that is something that can be done. We're going to hook this up to a power supply. What I have are two thumbtacks here, and they are specially coated with a conductive material. I need to put them in here, and I need to make sure that when I push them in, that the bottom of the tack touches the paper, so it is sort of a complete, we can get a complete circuit going. And I'm going to put one over here. And the reason why we need the tacks in here is that I'm going to hook a power supply up to this and get 12 volts, roughly 12 volts across these two things. And then we're going to look at what is the electric potential at various points on this piece of paper. There are numbers along the side here, so the coordinate system that's listed in the lab are based upon these numbers that are right here. And so it's each of the bigger lines is 5, and then it's broken up into smaller points right here. So this is the point 310, and this is 2210. So for procedure 0 with a digital multimeter, this is a digital multimeter. This presumably is the first time this is being used in this course. It is used for measuring various things. So I can measure voltage here. I can measure resistance, that's the symbol for ohms, that's the symbol for volt. This is for measuring diodes. That's the symbol for capacitance, that measures frequency. And then we have three things here for measuring current, depending upon how much current there is. So usually if you're trying to measure current, you calculate what you expect the current to be, and then that sort of determines what you set it on. The difference is that if you're in the wrong mode, your results could be incredibly far off. And then you can also measure temperature here. We also have, so if I put this, if I want to measure voltage, so I put it on volts, we should be getting something close to 0 here. And notice in the corner right here, it says DC. If I was measuring AC, which just happens later in the course, I just press that button right there, that changes to AC, and then back to DC. It does assume that for measuring AC, it does assume a frequency of 60 cycles a second. And actually, we can measure the voltage of our outlet right here. If you're uncomfortable doing this, definitely do not do this at home. So I'm going to take my two leads and just stick it in the socket. That is the plug for my computer, and the battery is shot, so if I unplug that, my computer would completely shut off. So I just put the two leads right in there. The sampling rate matches the frequency of what's being done. So it's about 37 millivolts right there. If I plug in again, Notice we have a different value that is sort of honing in on. If I take these out and plug it in a third time, and it picks a different value. Because this thing's oscillating back and forth very quickly. But if I put this on AC, we're getting just shy of 120 volts, which is what our voltage is. And so this gets into various issues, which we'll discuss at a later date in the course. Notice we have two sides to our power supply here. We have a DC side and an AC side. Another way that you can tell the difference is that the DC side has two different colors here for high potential and low potential. And then over here, they're the same color because the voltage will flip back and forth about which one's the high side and which one's the low side. Standard color scheme is set up like this, where this is the high potential and this is the low potential. We have a dial here that, and based in terms of percentage, it claims it's 12 volts. It actually, some of them will go up to 14 volts or 13 point something volts, and we'll figure out what that max is. And then there's the on off switch. We do have a breaker here sometimes that we do short it out, and so we have that DC breaker there, the AC breaker here, and then there is one on the back side. And so this is a reset switch for the circuit breaker over here as well. A little safety tip here is that whenever you're measuring current, do not put the multimeter on the current setting. And then take the two ends and stick them right into there. I think if you read Dante's Inferno, I believe one of the levels of hell is for people who do that. I might have to recheck that. What happens is that you'll break the fuse in here, and then somebody has to go through, remove it, grab a new one, and so forth. It's a pain in the butt. So we're going to connect the lead from the power supply to the tacks. Initially start with the red clip attached to the 310. So I'm going to maintain the color code in here. So I have a red clip here, which I'm going to attach to the 310. And then this one side is going to attach over here. Now there are fancier ways of doing this, but you know, this works. And then I'm going to connect the black lead, and again, maintaining the color scheme. So I attach one end over here, and the other end over here. Now this is an insulating material right here, so I'm making a connection because of the side of it, which is stuck inside there, because it's metal inside on the other side of this plastic, and so that's where the connection's being made. We'll plug this in. And the shaky camera you can think of as cinema verite. I turn this on and I crank it up. Now it's somewhere around 100%. Let's figure out what the potential difference is between the two leads here. I have this set on volts. And I touch the two leads. Oh, I'm still on AC. Put it on DC. I touch the two leads, and I'm at 13.75. I put the red probe on the 2210 tack and the black probe on the 310 tack, and I get negative 13.75. Let's put it closer to 12, so I'm going to reduce the output just a little bit. Now, it's not crucial that it be at 12 volts. This is more of me being anal retentive. But part of my philosophy is that, you know, you take care of the little things, and then it naturally at some point becomes more of a part of you. Another reason I'm going for 12 is that I can do the math a lot easier in my head if I have to. So notice that with this setup, it is negative 12 volts. That is because the lead, which is expecting the high side, is connected to the low side, and the lead expecting the low side is connected to the high side. And so we basically are measuring this backwards. So that's why it's negative. And so now what I want to do is I'm going to flip these two leads, make sure it is a good connection here. And now I put the high side of the probe next to the high side of the power supply and the low side with the low side. And we should have, it's very close to the same value as we had before. We're off by 1/100 of a volt. but it is positive 12.18 volts. I'm hoping that you can read that one. Right now it's in millivolts, and that will change at some point. So I want to keep the black lead connected to this the entire time, and instead of just holding it there, I'm going to wedge it in here. And let's just make sure we're still getting 12 volts over on the other end. And I'm getting nothing, so there's a bad connection here. One of the problems was that the jostling around, I loosened the connection to the power supply. So let's take a look at that again. We're getting to what we had before. So I want to keep this probe connected to this the entire time, and it's just a whole lot easier if I could somehow wedge it in there. I still want to keep a good connection. If it is loose, we can have some other issues. And so let's just make sure that, and we're getting about what we had before. If the tacks are in properly, if I go halfway, I should be getting about half the value. I'm at 9 volts there, which is a little bit more than I would expect. So let's make sure we push these tacks down more. There we go, about 6.3. All right, so that's a whole lot better. So one of the things about doing this lab is we really need to not move the wires. And so that's one of the reasons why I have this wire tucked underneath and these pulled off to the side. And this is one of the issues when I did this already, and I basically have to start over again. And we have a coordinate system here, as potentially mentioned before, and making sure you can see the dial there. This should be 12 point something volts, and when I go to the middle, it should be somewhere around 6 volts, and it is. So I'm feeling that's close enough. So we're going to the point 510. So 3.09, and that is my target. So I'm going to write that down so I don't forget. Let's make sure I'm still roughly the same area here when I get the crosshairs. I'm looking for somewhere within plus or minus 0.03, so that was a 3.10, 3.09. So somewhere in the range of 3.06 to 3.13. So we have that point right here, and .27, that's too high. And the farther I get away from this, the higher it should get, so that's not too surprising. Let's come down. So that was the point I just did, was a 0.58. Now let's take the 0.47. And we probably get a little bit closer than that. This is 47.5. Nope, that does not work there. So the 0.47 works. Let's see if I can get one a little bit farther away. This is the 0.25. And that's pretty darn close. Let's see if I just cheat up just a little bit. There, that looks look good. That is the 0.2, about 5.2. Going to the other side because I want to spread this out. Now, ideally, there's a symmetry here, and reality is it's not necessarily going to be symmetric. But I'm looking at the 0.413. It's a little bit high, so 412.5, 412, 412.25. And there we go, it's not too bad. And let's pick a point over here. So the 0.214. And that's pretty darn good there. We can probably go in just a little bit. 213.5 to 13.75. And so it's probably enough to get a data point over there. So let's now go to the next one. So 7.5, 10 as a starting point here. So that's 4.2, and let me write that down just so that I remember that target. So 4.20. Now I do expect that then to sort of be circled around there, and then as we move out, it should flatten out, and so it won't be as tight a curve. That was 4.2. Let's just make sure we are still roughly in the same spot, and we are roughly in the same spot. Let's try the point down here along the 5 vertical. So let's look at, that was at, the first spot was at 7.5, 10. I'm now looking at the point 7, 5. A little bit high, so let's come in a little bit. So 6.5, 5. 6, 5. Too far. 6.25, 5. And we're shooting for, let's go back to that middle spot again. So 6.5, 5. Oh, that was on the low side, so let me move farther out. And that's 7, 5. So 6.4, 6.75, 5, and spot on. Now something around here. So the 0.50, a little bit low. 5, 6, sorry, 6, 0. 4.29. Let's go 5.5, 0, and there we go. Now going to the other side. Again, 4.2 is my target. Let's take a look at the point 7, 15. 6, 15. 6.5, 15. That's close. 6.25, 15. That's a little bit better. And then a point on the far side, and the point 6, 20. 5, 20. And there we go. That probably come in just a little bit. 4.75, 20. So it's somewhere in between 4.75 and 5 along the horizontal axis. Now let's go to the point 10, 10 to get a starting point. And that's 5.01. Let me write that down. So that is my target. We should be flattening out a little bit more here. So let's try the point 9, 5. And that's too low. 10, 5 is actually just slightly higher. That's definitely within the acceptable range. Let's see if we can narrow it, get that a little bit better. So 9.5, 5. 9.9, 5. It's looking like that 10, 5. Now looking like a little bit high. So that one's actually a little bit better, just shy of the 10 on the horizontal axis. And then 9, 0. 9.5, 0. And that's definitely within the range. If we just cheat up just a little bit over the halfway point, that's now it's maybe 9.6, 0. Now going to the other side. So it should be somewhere around here if the symmetry holds. And so this is the point 9.5, 15. Pretty darn close. And then if we look at the point 9, 20. Pretty darn close. So 9.25, 20 puts you over, so it's somewhere in that range. Now we go to the middle spot here. So this is the point 12.5, 10. This is the one that should be somewhere close to 6, and it is still close to 6. Not exactly the same number as we had before. Saw 5.8 the first time I did that. 5.76. So 5.77 seems to be my target there. So 5.77. And so now let's take a look at 12.5, 5. This is 13, 5. 12.75, 5. Looks like that's hitting it. And then on the edge here, we have at the point 12.5, 0. 12.75, 0. 13, 0. And that's slightly over where we were, our target, but definitely within the acceptable range. Going to the other side, looking at 12.5, 15. And that's definitely within the range, but let me just go over just slightly. So that is 12.25, 15, so somewhere in there. And looking on the outside here, so this is 12, 20, 12.5, 20, 12.25, 20, and that is definitely within what we're looking for there. Next spot, I'm looking at 1510. This gives me my target. So 6.6. I'm going to write that down so that I remember. One of the issues I had the first time I did this is I forgot to write down, and I ended up doing like 50 different spots. It felt like 50. All just because I could not remember. Just testing that again just to make sure it doesn't change radically, and it doesn't, still in that 6.60 range, so I'm going to keep that as my target. Now, taking a look at the point 16, 5, a little bit high, 15.5, 5, so somewhere between there, so 15.75, 5, and then the next point, 16, 0, 17, 0, 16.5, 0, and definitely within the acceptable range there. If I just go up slightly, I'm going to call it 16.6, 0. And then on the other side, 16, 15, 15.5, 15, 15, 15, so 15.25, 15, there we go. And 16, 20, 15.75, 20, so somewhere around there. All right, so the next spot, we are at 17.5, 10 as my data point, so 7.51 is my target. Going back, making sure we're in basically the same there. Yeah, it just all depends upon the exact spot I put it. So we are in that basically 7.5 range there. This should curve more than the last couple of them did. So let's take a look at, this is the point 18.5, 5. That is too low, so let's get closer to the red. So this is the point 19, 5. Of course, more than that. 19.5, 5. There we go, probably 19.25, 5. So somewhere in between those two. And then let's try 22.0. Boom. 22.1, 0. 21.25, 0. Now on the other side, we have, this is 21, 15. Way too high. 20, 15. 19, 15. 18.5, 15. 18.75, 15. We're within the acceptable range, so it's somewhere around there. And then the data point over here on the Y value being 20. So let's take a look at the point 2020. It's just a little bit low, so let's move more to the right. This is the point 2120. It's a little bit high, so and I forget the number I just did. So that was 21, 20. So 20.5, 20. 20.75, 20. All right. And then the last set of data points for this one We have the point starting out with at the point 20, 10. 8.70 is the target. Just touch that point again just to make sure that it hasn't strayed too much. I got 8.73, 8.71, so well, we definitely have a range there. Let's stick with 8.71 as our target. Now this should curve more dramatically than the others. Because you get to the positive or negative in, it should curve more. So let's take a look at the point 22, 7. That is a little bit too low. And got a little bit higher. Actually, if we go in the other direction, so let's take the point 22, 7.5, 22, 8, and that, try that again, tiny bit high. So 22, 7.9. That's pretty darn close. So somewhere in that range. And let's see if I can get another one on this side. So the point 24, 9. 25, 9. 25, 8. 25, 7. 25, 7.5, 25, 7.75, 25, 8 again. Oh, that's on the small side. Let's go the other direction. So 25, 8.5. There we go. On the other side, symmetry would be really nice about now. So let's pretend that it will work. So this is 25, 11.5, a little bit high. 25, 12. We're within the acceptable range there. And then I need another point over here. So 22, 13. 22, 12. 22, 12.5. 22, 12.75. 22, 12.6, somewhere around there. All right. And that should be it. That was a whole lot easier the second time around. Here is procedure B of the lab. And we're using parallel conductors here. The lab originally came with pens with a conducting gel in it, and you could write on it. It looked beautiful, except for the fact that the pens don't really work. I'm using aluminum foil to put all of this area right here on the same potential and all those on the same potential. And we can see how close we get. So first off, it should be somewhere around 12 volt difference here. So 12.03 volts, 2 volts, somewhere in there. I touch this tack over here. It's the same, or close enough, within 1/100th of a volt. And again, within 1/100th of a volt. But what about the aluminum itself? So if I touch the aluminum, and we're still in that same range. Now down here, when I touch it, since I'm finding the potential difference between where this lead is and where this lead is, if they're right next to each other, potential difference should be close to 0. Notice that the units are in millivolts there. And so it's 0.1 millivolt difference there. If I touch this tack, 1 point, that's still dropping. That's settled 1.1 millivolts, this tack right here. So 1.5 millivolts if I touch the aluminum next to it. 2.1 millivolts. And 2 millivolts. So they're all roughly the same, definitely at a level that we're not concerned about, because we're concerned about whether the potential difference is within 0.03 volts of whatever our target is, and this is definitely less than 30 thousandths of a volt. So I'm going to pick various points along here, very similar to the previous procedure. Let's also make sure that in the middle it's somewhere around 6. It is around 6, as I was hoping. So we're taking the point 910, that is the first suggestion. And hopefully it'll calm down. All right, so 3 point. It does seem to be a fluctuation when I do this lab. So let's see if I can hopefully not damage the paper. So it looks like about 3 point. Come on, settle down. I'm going to go with 3.48 since it seems to be dancing about that. I am going to write that down in case I forget. So 3.48 volts is the potential difference between this point right here and this strip right here. So now let's see if we can find another one. So I want something around in this range would be nice. How about here? That's 3.62. And I've already forgotten the number that I was going for, 3.48. So this is the point right here that is 9.6. And I want something a little bit smaller than that. So I want to get closer to the 0, which is down here. This is the point 8.6. That's too small. 8.5, 6. 8 3/4, 6. Getting closer. That is about 8.86. And now we're actually within the range that we like. See if I can find a point over here somewhere. This is the point 7.3. So this is the point 7.5, 3. 8.5, 3. 8, 3. Let's see, about 8.4, 3. 8.45, 3. Somewhere around there. And it's looking somewhere, it does actually look kind of like 8 point, looks like about 8.3, 3. Let's see if there's a spot on the side over here. I know it's more points than prescribed, but that's okay. So it's 1.7. I want to get farther away. I'm going to go off the board. So what about behind? This is the point 0.5. So it looks like it's sweeping out and then sweeping far behind it. Notice that on the other side of the parallel conductor, and we'll talk about this with parallel plate capacitors, the potential difference out here is close to 0. You know, it's under 1 volt there, whereas on this side, equidistant from it, I'm almost at 3 volts. So again, my target is 3.48. I'd like to find another point over here somewhere. How about the point 80? Ooh, nailed that one. And now over here, this is the point 8.13. Nope. 9.13. 8.5, 13. 8.75, 13. 8.8, 13. So you have a general idea where that is. And then over here, this is the point 8.16. 9, 16, 8.5, 16, 8.25, 16. So somewhere closer to 8.5, you know, like 8 point, that's 8 point, what would estimate is 8.4, 16. And let's see if we got a point over here. Ooh, and that is the point 8.19. Let's see if we got the one over here. This is the point 8.1. And that's close. 8.5, 1. Yeah, it's too big. 7.5, 1. All right. Let's go to the next spot. The next point I'm going to pick is the point 1110 as recommended. And that is 4 point, again, it's jumping around the place. At least we're not dealing with a thousandth place at this point. 4.91. Again, write that down. I'm writing that down because I do not want to forget. So now I want to pick another spot that's around 4.91. So let's pick this spot right here, which is 11.7. A little bit high, not much. So I'm going to come in just a hair. So that's about 10.9, 7. I would potentially be so bold to say that's 10.95, 7. 4.91 is my target. So let's pick another point right here. This is the point 12.5. This is the point 11.5. Let's come out this way. This is the point 11.4, 11.3, 11.2. We seem to be going in the wrong direction here. So let's pick this point right here. This is the point 10.2, 10.3, 10.4, 10.5, 10.6. Those values are roughly the same as I'm shooting down that. So let's pick, again, 11.5, 10.95. That's about right. 10.855. Let's see if we can get a point over on this side. So this is the point 11.13. Just a shiny bit high there. So I would 10.9, 13. .85, 13. Let's pick a point out here. So this is the point 11, 18. 10.5, 18. There we go. So notice how it's relatively even just along a straight line until you get to the edges and it starts to curve a little bit. Let's take this point right here. This is the point 1310. And to mark our new spot here, so that's 6.37. I also want to point out that when we went from this spot to this spot, we increased the potential difference by 1.43. When we went from this spot to this spot, we increased the potential by 1.46, almost the exact same thing. That's something to keep in mind here. Again, that was, I had 6.37. Yeah, there's 6.37. It really depends upon where I hit it exactly. But I want to find a couple other points there, so let's pick this point right here, which is 13.7. That's 6.28. I want something a little bit higher, so let me just scooch over to the right just a hair. 6.32, just a little bit more. All right, that's about it. That's at the point 13. It's about 13.1, 7. And let's pick a point over here. And actually, I'm going to hit the middle first. So it's 13.5, 3. I want just a scooch less. Let's see if we can actually go to 13.25, 3. And we're within the 0.03 margin. Depends on how I roll this. So that is, I would estimate, yeah, to me that looks like 13.25, 3. Going over to the other side, let's pick this point here. This is the point 13, 14. Just rolling it slightly to get down to 6.37, which was our target, or at least within that range. So that's looking like about 12.9 comma 14 as the data point. And then a point over here. This is the point 1319, 6.47. It's a little bit high of what we want, so let's scooch it over. So that's 12.75. That's too little. That's looking like about 12.9. That's looking like about 12.9 comma 19. And I think that'll be 5 data points there. So let's go to this point right now. So that was the point 1510. So the point 1510 gets us 7.78. Let's find some more points. How about right here? Let's go for a crosshair. So that's the 15,6 and 17.78. So I need a little bit higher. So let's just scooch over to the right a little bit and just a little bit more, a little bit more. There we go. And to me, that looks like about 15.2 comma 6. Picking a point out here, this is the point 16 comma 2, and that is just a little bit high. Let's move over, and actually let's do 15.5 comma 2, a little bit low, 15.75 ish comma 2, 15.8 comma 2, 15.9 comma 2. There we go. Over on the other side, let's pick this point right here. This is the point 1614, way high. 15.5 comma 14. 15.14, a little bit low. 15.1. 7.78. Let's go back to 1514. There we go, 1514. And then I want a point out here. So this is 1518. A little bit too low. That's getting better. 15.5 comma 18. 15.25 comma 18, 15.2 comma 18. And then the last set here, that was the 1510. Let's now go to 1710. So 9.16 is the target. 9.16 at 1710. Notice that, again, we have a progression. When we went from here to here, we had an increase of 1.43, then we had an increase of 1.46, now we had an increase of 1.41, and now we have 1.38 of an increase. So it's relatively consistent as we progress there. All right, so again, our target was written down, it's 9.16. So let's pick a point over here. So that's 17.6. 9.16 our target. Ooh, they're pretty darn close there. That is 17.5 comma 6. Let's pick a point over here. The point 18.2. 18.5 comma 2. 18.2 comma 2. All right, and then on the other side, let's go for this point right here. I'm gonna move over just slightly. So that point right there is 17.14, 17.1, 14. I would say 17.05, 14. So somewhere in there. And then I think the last data point, this is 18, 18, and that is too high. 17 and a half, 18, too low. 17 and 3/4, 18. And that should be it.